Welcome to the MSBTE online learning platform. We bring you the most relevant content in an exciting digital format. Today, we'll be studying a very interesting module from Applied Mathematics, Applications of Definite Integration, which includes topic Definite Integrals, where we will be studying some interesting facts about applications of definite integration. And we will be practicing some of the examples based on it. So, let us begin. The module we are learning from is Applications of Definite Integration. The topic we are going to learn today is of definite integrals. Let us see the learning objectives. Students should be able to apply method of definite integration to solve simple problems based on definite integration, applying the given limits, finding numerical value of definite integration. Let us see the learning outcomes. Understand the definition of definite integration. Application of the properties to solve problems of definite integrals. Alright, you all already know the concept of indefinite integration, which you all have learned in Unit 2. Let us see an example, a very simple example to understand and recollect what is indefinite integration. Integration of x plus 1 dx, that is equal to x squared plus 2 plus x plus c. So here integration x is integrated first as x squared by 2, then plus 1 dx integrated as x plus c, which is the constant of integration. This is a very simple example. Alright, let us see another example. Here a triangle is formed by the line y is equal to x, that is a line which is passing through the origin, and x is equal to 2, which is a line which is perpendicular to the x-axis. By applying definite integration for x is equal to 0 to x is equal to 2, we can find the area of the triangle. Now you all can see this is the line x is equal to 2, which is perpendicular to the x-axis and parallel to the y-axis. Then we have the line y is equal to x, which is passing through the origin. So we can see a triangle is formed here, alright, from x is equal to 0 to x is equal to 2. So we can find out the area of this triangle by applying definite integration, taking limits from x is equal to 0 to x is equal to 2. So you can see it has been colored to understand it better. Alright, if we apply the limits for given integral, then we get finite minimum value of the integral. Today we are going to learn the topic of definite integration. Students, do you all know where do we apply definite integration in real life? Can anyone give me an example? Alright, let us see this example here. Yes, you can see this picture. We have a lake which is having a motor, a pump attached to it, and there is a water purifier. The water is going to the water purifier. Through the pipeline, it is going to the society. And the generator is providing power to the water purifier as well as the motor at a varying rate. That means each and every minute, the power that is being provided is varying. So now what happens is, we need to understand and find out how many gallons of water is being pumped, say for 5 minutes. So since it is a varying rate, what will happen is, if we have a data analysis for every minute of gallons of water being pumped, that data analysis will determine a function, a continuous function with respect to t. Now what happens is, that function has to be integrated with respect to t to find out how many gallons of water is being pumped for 5 minutes. So now 5 minutes, that will be the time limit taken from 0 minutes to 5 minutes. So the integration is from 0 to 5 minutes for the continuous function with respect to t. That will give us the gallons of water being pumped for every 5 minutes. I hope that you all are clear with the topic of definite integration and its application, where you are going to use it in the real life. Alright, let us see the definition of definite integration. We have already studied that integration of f of x dx is equal to some function g of x plus c, which is the constant of integration. This is how we define indefinite integration. Now, in the same way, we are having the definition of definite integration as integration from x is equal to a to x is equal to b, f of x dx is equal to some function g of x from a to b, that is equal to g of b minus g of a. This x is equal to a and x is equal to b are defined as limits, and they are called as, where a is called as the lower limit and b is called as the upper limit of integration. So, the integration will be done for the function f of x, and then limits are going to be applied, in the sense first you will have the upper limit being applied, that is you take x is equal to b minus lower limit, that is you take x is equal to a, to solve. Hence, what you will be getting is a constant value. The definite integration you can see here is independent of the constant of integration c, because you already will be getting a constant value, so you need not write down a plus c when you are solving definite integrals. Let's take a very simple example first. I is equal to integration from 0 to 1 x plus 1 dx. So, we are going to integrate the function x plus 1 how we integrate any other function, alright, with respect to x. So, integration of x plus integration of 1. So, what do we get here? Integration of x, x squared by 2, integration of 1 is x. Now, what you can see here is after integration, we still are writing the limits from 0 to 1. That means after the step of integration, you need to apply the limits, which we should not forget to do. So, the limit application would be like this, where you will apply the upper limit first, that is taking x as equal to 1. So, 1 by 2 plus 1, that will be the application of the upper limit, minus the lower limit is 0, that means when you take x as equal to 0, you get the value as equal to 0, and hence you get the answer as 3 by 2. I hope you all have followed, students. This is a very simple example. Let us see another example. It is a trigonometric function which we are integrating. Integration from 0 to pi by 2 cos x dx. Now, we know that the integration of cos x is sin x. So, integration of cos x sin x, again limits from 0 to pi by 2 has to be applied on the function after integration, and that is like this. That is, first you apply the upper limit, then you apply the lower limit. So, sin pi by 2 minus sin 0, and that will give us 1 sin pi by 2. I hope you all are knowing that sin pi by 2 is nothing else but sin 90, and the value of sin 90 is 1. So, 1 minus 0, hence the answer is equal to 1. Alright, let us see this example where I is equal to integration from 2 to 3, 1 upon x plus 1 into x plus 2 dx. Can you identify what kind of an integrand are we going to integrate here? 1 upon x plus 1 into x plus 2. If you recollect, we are supposed to solve 1 upon x plus 1 into x plus 2 by the method of partial fractions. So, let us see here. Let us see, this 1 upon x plus 1 into x plus 2. Now, you can see they are linear distinct factors. Okay, so that is of the type 1 in partial fractions. So, that is a upon x plus 1 plus b upon x plus 2. So, when you solve, you get this as 1 is equal to a into x plus 2 into b plus b into x plus 1. I hope you all are remembering how to solve partial fractions, which you all have done in the semester 1. Then when you take the value of x is equal to minus 2 here, we get the value of b is equal to minus 1, and when you take the value of x is equal to minus 1, you get the value of a as equal to 1. Hence, the value of a is 1 here and the value of b is minus 1. So, we substitute those values here and we get the partial fractions, which is like this. You can see, so it is 1 upon x plus 1 minus 1 upon x plus 2. Now, we integrate. So, this is going to be integrated in this form, writing down whatever we got after doing the partial fractions. Integration from 2 to 3, 1 upon x plus 1 minus 1 upon x plus 2. Now, how do we integrate this? Integration will be done by using the formulas that you have already studied when you have done the chapter of indefinite integration. So, here this is in the form 1 upon ax plus b. In fact, both the terms are in the form 1 upon ax plus b. So, what is the integration of 1 upon ax plus b? It is 1 upon a log of ax plus b plus c. So, that is the formula that we are going to apply to integrate here. And you can see log of x plus 1 minus log of x plus 2, limits taken from 2 to 3. So, here we complete the part of integration and now we apply the limits. So, limits, before application of the limits, we are using here the law of logarithm, log m minus log n is equal to log of m by n. So, using that law of logarithm, first we simplify it in this way and then we will be finding the value or finding the final answer. So, here application of the upper limit, that is taking x as equal to 3. So, this is 4 by 5 and then taking the lower limit x is equal to 2. So, it becomes log of 4 by 5 minus log of 3 by 4, and again using the law of logarithm, log m minus log n is equal to log of m by n, and that will give us the value as log of 16 by 15. That is the 4 by 5, the fraction 4 by 5, and the fraction 3 by 4 is actually multiplied in the form 4 by 5 into 4 by 3. So, this becomes log of 16 by 15. I hope you all are following, students. Example where you are having integration from 2 to 4, 1 upon 2x plus 3 dx. Again, recollect, this is in the form 1 upon ax plus b. Now, what is the integration of 1 upon ax plus b? It is log of 1 upon a log of mod of ax plus b. You can see it is here and the formula is highlighted for you all. Integration of 1 upon ax plus b, 1 by a log of ax plus b plus c. So, that formula is applied here and we get 1 by 2 log of 2x plus 3, where the limits have to be applied from 2 to 4. Yes. So, after the limits has been applied, we get half into log of 8 plus 3 minus log of 4 plus 7. That is upper limit minus lower limit. So, we get log half into log of 11 minus log 7. Again, using the law of logarithm, log m minus log n, which is equal to log of m by n, we will get half into log of 11 by 7. Alright, let us see this example. It is integration from minus 1 to 1, 1 by 1 plus x squared dx. Now, actually, this is itself a formula, integration of 1 by 1 plus x squared. It is a formula that you will have used in indefinite integration. 1 by 1 plus x squared is integrated as tan inverse x. So, you can see here. So, it is the answer of the integral is tan inverse x, that is for 1 by 1 plus x squared integrated as tan inverse x from limits from minus 1 to 1. Again, first we take limit, upper limit taking x is equal to 1, then minus lower limit taking x is equal to minus 1. So, we get tan inverse 1 minus tan inverse minus 1. Now, this is one of the properties of inverse trigonometric functions that you all have already studied in the first semester, and that is tan inverse minus x is equal to minus tan inverse x. So, this property is applied for this part what we got here. So, this becomes tan inverse, it becomes tan inverse minus 1 becomes minus tan inverse minus 1. So, what we get here, it becomes a plus. So, we get tan inverse 1 plus tan inverse 1. Now, what is the value of tan inverse 1? Anybody can tell me what will be the value of tan inverse 1, or rather tan of what angle gives us the value as 1? Yes, tan 45 gives us equal to 1. What is 45 in radians? 45 in radians is pi by 4. So, the answer for tan inverse 1 will be pi by 4. So, pi by 4 plus pi by 4, which will give us the answer as pi by 2. Another example, a trigonometric function, again we are going to integrate 0 to pi by 4 cos squared x dx. Now, we don't have any formula to integrate the square of a trigonometric function. Hence, we are going to use some trigonometric formula here to first simplify the given function and then we will integrate. So, the formula that we are going to use here is, yes, look here, cos squared x, we know this formula, 1 plus cos 2x by 2. This formula has also been used and found in the first semester that you all have done. So, cos squared x is equal to 1 plus cos 2x by 2. This is the formula that we are going to use here for cos squared x dx. So, it will be written as integration from 0 to pi by 4 of 1 plus cos 2x by 2. Now, this is a function which we can integrate. And how it is going to be integrated? First, the 2 which is in the denominator comes outside the integration sign, since we do not integrate constants here which are with variables. So, if they are constant coefficients, we need to take them outside the integration sign. So, 1 by 2 and we integrate 1 plus cos 2x. Integration of 1 you can see is x plus integration of cos 2x is sin 2x by 2, because this becomes a composite integral. Then we will apply the limits. First we apply the limit which is the upper limit, that is taking x as equal to pi by 4. Remember to put brackets wherever necessary, because this half is right outside. So, here first we take x as equal to pi by 4. So, x is pi by 4 plus sine 2 times pi by 4 upon 2 minus what we are doing here is now taking the limit, the lower limit x as equal to 0. So, 0 plus sine 0 by 2. So, wherever is in x, I have substituted that x as equal to 0. So, what we get now is, you can see this 2 and this 4 gets cancelled. So, we get a sine pi by 2. Sine pi by 2 is sine 90. So, when we solve this, what we get is a half into pi by 4. So, this sine 90 becomes a half. So, this becomes pi by 4 plus this half here, and this entire bracket will become 0. So, the answer would be half into pi by 4 plus half. Okay, let us see this example. It is integration from minus 2 to 4, 1 by x squared minus 2x plus 10 dx. We have a quadratic equation in the denominator. Usually, how do we solve a quadratic equation if it is given in the denominator? There are two ways. One, we check whether the quadratic equation can be factorized. If it can be factorized, we factorize it and solve it with the help of partial fractions. But if it cannot be factorized, what is the next method that we do? The next method, of course, would be the third term formula, which we will use and make the quadratic equation in the denominator in the form x squared plus or minus a squared. That is how we are going to bring the denominator as. Let us see here. Yes. So, here you can see the third term formula, which is half into coefficient of x the whole square. Here the coefficient of x you can see is minus 2. So, when you take coefficient of x as minus 2, the answer you get for the third term is 1. So, we will add and subtract the third term after the middle term. Okay, that means after minus 2x. So, adding and subtracting. So, plus 1 minus 1 and the plus 10 follows as it is. Now, what you can see is this x squared minus 2x plus 1 becomes a perfect square, which is x minus 1 the whole square, and minus 1 plus 10 becomes plus 9. Also, we are going to use this formula, which is integration of 1 by a squared plus x squared, which is equal to 1 by a tan inverse x by a plus c. So let us see now what we get after making the denominator into perfect squares. Yes, so we get 1 upon x minus 1 the whole squared plus 9. So you can see, is it in the form 1 upon x squared plus a squared? Can you identify it in that way? Yes, students, it is in the form 1 upon x squared plus a squared. Alright, so using the formula which we saw in the previous slide, we get the answer as 1 by 3. Now this 1 by 3 is actually 1 by a. Here a is nothing else but 3 because a squared is 9, hence a is equal to 3. So 1 by a tan inverse x by a becomes x minus 1 by 3 and the limits to be applied is minus 2 to 4. Now as I again said, the 1 by 3 which is a constant coefficient is to be taken outside the limit sign because you are not applying the limits on a constant, you are applying the limits only on the variable x. So what do we get when we apply the limits? We get, when we take x as equal to 4, that is the upper limit, we get tan inverse 3 by 3 minus application of the lower limit, that is taking x as equal to minus 2. So we get tan inverse minus 3 by 3. So basically what we are getting is tan inverse 1 minus tan inverse minus 1. Here you are. See, 1 by 3 tan inverse 1 minus tan inverse minus 1. Again tan inverse minus 1 will be, we will be using the property again. Which is that property, students? Tan inverse minus x is equal to minus tan inverse x. Using that property here again, we will get the answer as 1 by 3 pi by 4 plus pi by 4 since tan inverse 1 is equal to pi by 4. Here pi by 4 plus pi by 4 has been simplified further to get the answer as pi by 2. So here 1 by 3 into pi by 2, final answer is pi by 6. So students, what did we cover? What were our objectives? That is what we are covering here, the objectives. So let us see the objectives that we have covered here. Students should be able to apply the method of definite integration to solve simple problems based on definite integration. And yes, we have right now just seen how to solve simple problems based on integration. That is, we have integrated the given integral given to us, we have integrated, and after that we have applied the limits to find a certain value. Applying the given limits, that is, we applied the limits and we found a numerical value of the definite integration. So we have covered both the objectives in the problems that we solved earlier. Alright, let us see what is the conclusion. We applied the limits to the integration and solved it. So each and every sum we have applied the limits at the end after integration and found an answer, a numerical value to the integration. Yes, students. So do you have any questions with whatever questions and problems that we have solved right now?
Yes, ma'am, I have.
Yes, let me know.
What is the difference between integration and definite integration?
Alright, that's a very good question that you have asked. What is the difference between integration and definite integration? You all have already known what is indefinite integration, where you have solved a function, alright, with respect to x. You have integrated a function with respect to x. Now here, when you are solving definite integration, you are having limits to the integral. Limits, that means you are having a lower limit and an upper limit. That is how we define it as a definite integration. When you did not have any limits, you defined it as indefinite integration. So that is the first difference that you can identify between indefinite integrations and definite integration. And the next thing is, you are having a constant of integration plus c when you are solving indefinite integration. But that does not occur when you are solving definite integration because you get a numerical value after solving every problem on definite integration. Hence, the constant of integration is not required. I hope I'm clear with everyone, all the
Yes, ma'am.
students. Okay,
Thank
that's
you.
good. Now you are fully competent to solve the problems of definite integrals. So, a worksheet has been given below. Why don't you all try to solve it? Alright, I've given the solution of the worksheet also so that you all can cross-verify whatever you all have solved. First one, which was integration of x squared, limits is given from -1 to 1. You can see we have solved it in the same way by first integrating x squared and then applying the limits. What you need to remember is this step which has been highlighted here. This is where you need to apply the limits. You should not forget. After integration, sometimes you tend to forget to apply the limits, so you will not be able to obtain this answer. If this is not done, you lose marks. So please remember to apply the limits once you complete the integration. Yes, here also you can see it has been integrated and then limits have been applied. 5x upon 4 plus x squared, that has to be integrated from 0 to 2. What has been done here? Now the step which you need to remember, or rather you have to know how to solve, is this step. Here what has been done is, here you have multiplied and divided with 2 in the given function. Reason is because we are going to bring it in the form f dash x upon f of x dx. Now that is a formula. What is the integration of f dash x upon f of x dx? Yes, students, it is log of mod of f of x plus c. So only after multiplication with 2 can you proceed and use that formula. And that is what has been done here. The next example, where you have to take root x, you have to integrate root x, where the integration is from 1 to 4. What has to be remembered here is that you cannot integrate root x directly, you need to bring it in the form x raised to half. The root sign is always taken as a power of half. So you first take a power of half and then you integrate it in the way using the formulas and applying the limits. Here integration from 0 to 1, 1 upon 4 minus x squared. Alright. Now here what is important is what formula of integration to be applied. You can see here it has been highlighted, that is the formula integration of 1 by a squared minus x squared. See here it is 1 by 2 squared minus x squared. So the formula, this formula of integration has been applied for 1 by 2 squared minus x squared. So you need to remember this formula, then only the application will be possible for you. And then after that, after integration, the limits have been applied and an answer is derived. Then we have 13 plus x squared minus 6x. Again, a quadratic equation in the denominator. So if you remember, we solved a similar type of sum where you have used the third term formula. So you can see third term formula will give us a plus and minus 9. So this plus and minus 9 is important for you all to remember and understand that you are using the third term formula and bringing it in the form 1 by x squared plus a squared. So you are going to integrate it in the form 1 by x squared plus a squared dx, which is 1 by a tan inverse x by a plus c. Again, the formula has to be learned, remembered and memorized so that you will be able to apply them. So that is what we are doing here also. And then we come to an answer after the application of the limits. Alright, the next topic that we are going to cover up would be properties of definite integrals. Thank you. You have learned some important topics so far, and we hope you had a good time learning with us. Browse through our online library for more content on the MSBTE website. Thank you. Stay connected. Happy learning.